Hello everyone, today we are going through formation of quadratic polynomials. So here we will study how to write the quadratic polynomial when zeros are given. Okay, so let's take if alpha and beta are the zeros of polynomial ax square plus bx plus c. In last class we have already studied alpha plus beta. If alpha and beta are the zeros of the polynomial ax square plus bx plus c, then what is alpha plus beta? That is minus b by a. And alpha into beta is equal to c by a. Right? Now let's substitute it here. Okay. So here ax square plus bx plus c. This can be written as x square plus b by ax plus c by a. Okay, divided throughout by a. Then it is equal to, see here let's substitute. What is b by a? Minus of alpha plus beta. Alpha plus beta is equal to minus b by a. Therefore b by a is minus of alpha plus beta. So it will be x square, b by a is minus of alpha plus beta into x plus what is c by a? Alpha into beta. Okay. So here if alpha and beta are the zeros of the polynomial, then the quadratic polynomial will be x square minus alpha plus beta into x plus alpha into beta. It's very important. If alpha and beta are the zeros of the quadratic polynomial, then quadratic polynomial will be x square minus of, okay, don't be confused, minus of alpha plus beta into x plus alpha into beta. Now let's go through some important questions. First question, if alpha and beta are the zeros of a quadratic polynomial x square minus 5, then form a quadratic polynomial whose zeros are 1 plus alpha and 1 plus beta. Okay, here it is given that alpha and beta are the zeros of the polynomial x square minus 5. Now here we can find the zeros of this polynomial. Means we can find the values of alpha and beta, right? That is x square minus 5. This can be written as x plus 5 into x minus 5, right? Because it is of the form a square minus b square, right? That is a plus b into a minus b. So here two factors, x plus 5 and x minus 5. So how to find the zeros? That is x plus 5 is equal to 0 implies x is equal to minus 5. X minus 5 is equal to 0 implies x is equal to 5. So what are the zeros? 5 and minus 5. Okay. Now here let's take, let alpha is equal to, that is two zeros, alpha and beta. Here we have got the values of alpha and beta. Okay. Now let's take alpha is equal to 5 and beta is equal to minus 5. Okay. Now here we can find the zeros. 1 plus alpha and 1 plus beta. Okay. So 1 plus alpha is equal to 1 plus 5, that is 6. 1 plus beta is equal to 1 plus minus 5, that is equal to minus 4. So what are the zeros? 6 and minus 4. Now here we have to form a quadratic equation which has the zeros 1 plus alpha and 1 plus beta. Okay. So here let's write, we know that if alpha and beta are the zeros of the quadratic polynomial, then the quadratic polynomial will be x square minus alpha plus beta into x plus alpha into beta. Okay, here alpha and beta are the zeros of this polynomial. Here what are the zeros? 6 and minus 4, right? So the required polynomial, quadratic polynomial is x square minus alpha plus beta. That is 6 plus minus 4. 6 plus minus 4 into x plus alpha into beta. 6 into minus 4. Okay. So required polynomial is x square minus of 6 plus minus 4 into x plus 6 into minus 4. That is equal to x square. Here 6 plus minus 4 is 2. So minus 2x. Here 6 into minus 4 minus 24. So required quadratic polynomial is x square minus 2x minus 24. Look at the next question, an easy question. Find a quadratic polynomial, the sum and product of whose zeros are minus 3 and 2. If alpha and beta are the zeros of the polynomial, alpha plus beta, that is sum of the zeros, that is given minus 3. And product of the zeros, alpha into beta, that is equal to 2. Okay, it's a CBSE 2020 basic mathematics question. Okay, so here alpha plus beta and alpha beta are given. Directly you can substitute in the quadratic polynomial. Okay, that is x square minus alpha plus beta into x plus alpha into beta, that is equal to x square minus of alpha plus beta is minus 3. So minus of minus plus 3x plus alpha into beta 2. So it is the required quadratic polynomial. Next question, an important question. If zeros alpha and beta of a polynomial x square minus 7x plus k are such that alpha minus beta is equal to 1, then find the value of k. See, first of all, what is given here? It's given that alpha and beta are the zeros of this polynomial. Okay, alpha and beta are the zeros of the polynomial x square minus 7x plus k. Okay, here we need to find the value of k. So first of all, here we know that if alpha and beta are the zeros of the polynomial, then the quadratic polynomial in the form x square minus alpha plus beta into x plus alpha into beta. Right? Here alpha and beta are the zeros of this polynomial. And it is given that alpha and beta are the zeros of this polynomial. Right? So equate this. So it is equal to x square minus 7x plus k. Right? That implies alpha plus beta is equal to minus 7. Right? On comparing both sides, here we will get alpha plus beta is equal to minus 7. Sorry, plus 7, right? Minus of alpha plus beta. Minus of 7. Okay? So alpha plus beta is equal to 7. See, here we have two equations. Alpha minus beta is equal to 1 and alpha plus beta is equal to 7. So from these two equations, we will get the value of alpha and beta by solving these two equations, right? So here alpha minus beta is equal to 1. Add these two equations, we will get, so that this beta will be cancelled, right? So alpha plus alpha, 2 alpha is equal to 7 plus 1, 8. That implies alpha is equal to 4. Okay. So here we have got alpha is equal to 4. Then substitute this alpha is equal to 4 in any of these equations. That is, okay, 4 minus beta is equal to 1. That implies minus beta is equal to 1 minus 4. That is minus 3. That implies beta is equal to 3. Right? So here we have got the values of alpha and beta. We need to find the value of k. What is k? K is nothing but alpha into beta. Okay? K is alpha into beta. So here on comparing these two equations, we will get alpha plus beta is equal to 7 and alpha into beta is equal to k. Okay? So k is equal to alpha into beta. That is equal to alpha is, value of alpha is 4 into beta is 3. That is 12. So the value of k is 12. If alpha and beta are the zeros of the polynomial 2y square plus 7y plus 5, then find the value of alpha plus beta plus alpha into beta. Okay. So first of all, let's write, if alpha and beta are the zeros of the polynomial, then polynomial is of the form x square minus of alpha plus beta into x plus alpha into beta. Right? And here it is given, okay, let's write in y, okay, variable y. It is our polynomial, given polynomial is in y variable, okay. So here let's take y square minus alpha plus beta into y plus alpha into beta, okay. So given polynomial 2y square plus 7y plus 5. So here to compare these two polynomials, here we have to make coefficient 1 because here coefficient of y square must be 1 to compare, okay. So here let's make it 1, that is 2y square plus 7y plus 5, that is equal to, see, divide throughout by 2, we will get y square plus 7 by 2 plus 5 by 2, right, y square plus 7 by 2 y plus 5 by 2, okay. Now here, see, we need minus, right? So let's take here minus of minus 7 by 2. Okay? Minus into minus plus, right? Okay. So here, now let's compare this because here it is given alpha and beta are the zeros of this polynomial and alpha and beta are the zeros of this polynomial, right? So therefore, it is equal to, that is y square minus alpha plus beta into y plus alpha into beta, that is equal to y square minus of minus 7 by 2 y plus 5 by 2. Understood? That is, it is given that alpha and beta are the zeros of the polynomial 2y square plus 7y plus 5. And we know that if alpha and beta are the zeros of the polynomial, then quadratic polynomial will be y square minus alpha plus beta into y plus alpha into beta. Right? Now we have to compare to find the alpha plus beta and alpha beta values. Right? See, if we know alpha plus values of alpha plus beta and alpha into beta, we can substitute it directly here. Right? So here, to find alpha plus beta and alpha into beta, we have to compare these equations, right? Polynomials. To compare, we have to make the coefficient to 1, right? So here, given polynomial, here coefficient of y square is 2. So we have to make it 1, right? So divide throughout by 2. What we will get? Y square plus 7 by 2 y plus 5 by 2. So here, see, it is minus of. You just make minus, okay? Take minus outside. That is minus of minus 7 by 2. Now compare these two polynomials. That is, here, what is alpha plus beta? That is minus 7 by 2. So on comparing both sides, we get alpha plus beta is equal to minus 7 by 2 and alpha into beta is equal to 5 by 2. Okay. Now, what we have to find? We need to find the value of alpha plus beta plus alpha into beta. Okay. Alpha plus beta plus alpha into beta, that is equal to, what is alpha plus beta? Minus 7 by 2. Okay. Plus what is alpha into beta? 5 by 2. Now minus 7 by 2. Okay. Minus 7 plus 5 minus 2 by 2, that is minus 1. So the value of alpha plus beta plus alpha into beta is equal to minus 1. A similar question, if alpha and beta are the zeros of 4x square plus 3x plus 7, then find the value of 1 by alpha plus 1 by beta. See, here also we have to find the value of 1 by alpha plus 1 by beta. On seeing this, we know what is 1 by alpha plus 1 by beta. After taking LCM, here we will get alpha plus beta divided by alpha into beta. So here also we have to find the values of alpha plus beta and alpha into beta. Okay, and given that alpha and beta are the zeros of this polynomial. And we know that if alpha and beta are the zeros of the polynomial, then polynomial will be x square minus alpha plus beta into x plus alpha into beta, right? And it is given its zeros, alpha and beta are the zeros of this polynomial. So first of all, we have to compare, right? find the alpha plus beta and alpha into beta. To compare, here we have to make the coefficient of x square 1. Okay. So, given equation polynomial is 4x square plus 3x plus 7. Now, divide throughout by 4. So, what we will get? X square plus 3 by 4 x plus 7 by 4. Again, this can be written as x square, take minus outside, minus of minus 3 by 4. Because minus of minus become plus, right? So, plus 3 by 4 into x plus 7 by 4. Okay. Now, it is equal to, because here also alpha and beta are the zeros of this polynomial, and here also alpha and beta are the zeros of this polynomial. So, this polynomial is equal to x square minus of minus 3 by 4 into x plus 7 by 4. Okay. On comparing both sides, we will get alpha plus beta is equal to minus 3 by 4 and alpha into beta is equal to 7 by 4. Okay. Now what we have to find? We need to find 1 by alpha plus 1 by beta. That is nothing but take LCM alpha plus beta divided by alpha into beta. Okay, LCM is alpha into beta. Okay, that is equal to, what is alpha plus beta value? Minus 3 by 4 divided by alpha into beta is 7 by 4. Here 4 cancelled, then minus 3 by 7. So the value of 1 by alpha plus 1 by beta is minus 3 by 7. Look at the next question. If one zero of the polynomial 3x square minus 8x plus 2k plus 1 is 7 times the other, then find the zeros and value of k. See, here it is given one zero is 7 times the other zero. Okay. So let's take alpha and beta are the zeros of this polynomial. Okay. And it is given, see, here 1 0 is 7 times the other. So let's take only 1 0, that is alpha. Okay, if alpha is 1 0, then another 0 is 7 times of alpha. Okay, that is alpha and 7 alpha. Okay, alpha and 7 alpha are the zeros of this polynomial. Okay, first of all, let's write the general polynomial. If alpha and 7 alpha are the zeros of the polynomial, then the polynomial will be x square minus of alpha plus beta. If alpha and beta, then alpha plus beta. Here alpha plus 7 alpha, that is 8 alpha. So here we can write minus 8 alpha x plus alpha into beta, that is alpha into 7 alpha, that is 7 alpha square. Okay. Now, it is given, see, actually alpha and 7 alpha are the zeros of this polynomial. 3x square minus 8x plus 2k plus 1. Okay. Now here we can compare these two polynomials. Right. Before comparing, see, you should be careful about this. This coefficient of x square must be 1. Okay. So we have to make the coefficient of x square 1. So divide throughout by 3. We will get x square minus 8 by 3x plus, see what is the constant term here? It is not only 1, 2k plus 1. 2k plus 1 is the constant term. Okay. So 2k plus 1 divided by 3. Okay. Now let's compare these two polynomials, because see, alpha and 7 alpha are the zeros of this polynomial, and it is given alpha and 7 alpha are the zeros of this polynomial, right? So this polynomial is equal to x square minus 8 by 3x plus 2k plus 1 divided by 3. Okay, on comparing these two equations, we will get minus 8 alpha is equal to 8 by 3, right? That is 8 alpha is equal to 8 alpha is equal to 8 by 3. That implies, see, 8 cancelled, right? So alpha is equal to 1 by 3. Okay. Now, we have to find the zeros and the value of k. Now, we have got one 0, right? That is alpha. Another 0 is 7 alpha, that is equal to 7 by 3. 7 into 1 by 3, that is 7 by 3. So, what are the zeros? Zeros of given polynomial are 1 by 3 and 7 by 3. Okay. Next, we need to find the value of k. See, here k, where is k? In constant term, right? That is 2k plus 1 divided by 3 is the constant term. So, let's compare these two. So, here 7 is equal to 7 alpha square, it is the constant. Okay, here it is the constant term, here it is the constant term. So, 7 alpha square is equal to 2k plus 1 divided by 3, right? Comparing these two equations, 7 alpha square is equal to 2k plus 1 divided by 3. Okay. That is, here what is alpha? Alpha value is 1 by 3. So, 7 into alpha square is 1 by 9. Okay. 1 by 3 square. That is equal to 2k plus 1 divided by 3. Here 3 cancelled. So, now it becomes 7 by 3. 7 by 3 is equal to 2k plus 1. That implies 2k plus 1 is equal to, take 1 left side. So, 7 by 3 minus 1. 7 by 3 minus 1. That is equal to 4 by 3. Right? That implies k is equal to 2 cancelled, right? So, k is equal to 2 by 3. So, the value of k is 2 by 3. And what are the zeros? 1 by 3 and 7 by 3. If the zeros of the polynomial x square plus px plus q are double in values to the zeros of 2x square minus 5x minus 3, then find the values of p and q. Here, zeros of this polynomial are double in the values to the zeros of this polynomial, right? So, here let's take alpha and beta are the, if alpha and beta are the zeros of this polynomial, then 2 alpha and 2 beta are the zeros of this polynomial. Okay. So, let's take, let alpha and beta be the zeros of 2x square minus 5x minus 3. Okay. Now, here this can be written as, see, let's make the coefficient of x square 1 by dividing throughout by 1. Okay. X square minus 5 by 2 x minus 3 by 2. Okay. Now, we know that if alpha and beta are the zeros of the polynomial, then polynomial will be x square minus of alpha plus beta into x plus alpha into beta. Okay. That is equal to, here alpha and beta are the zeros of this polynomial, right? So, this polynomial is equal to this one, that is x square minus 5 by 2 into x minus 3 by 2. On comparing both sides, here we will get alpha plus beta is equal to, alpha plus beta is equal to 5 by 2, okay, and alpha into beta is equal to minus 3 by 2, okay. Then, and it is given if alpha and beta are the zeros of this polynomial, then what are the zeros of this polynomial? 2 alpha and 2 beta. See, it is given zeros of the polynomial x square plus px plus q are double in the values to the zeros of this polynomial. Okay. So, if alpha and beta are the zeros of this polynomial, then 2 alpha and 2 beta. Okay. 2 alpha and 2 beta are the zeros of the polynomial x square plus px plus q. Okay. So, here 2 alpha and 2 beta are the zeros of x square plus px plus q. Okay. Now, here it is already 1, coefficient of x square is 1. Now, We know that if 2 alpha and 2 beta are the zeros of the polynomial, then polynomial will be x square minus of 2 alpha plus 2 beta. Okay. If alpha and beta, alpha plus beta. Here it is 2 alpha and 2 beta. Okay. 2 alpha plus 2 beta into x plus alpha into beta, that is 2 alpha into 2 beta, 4 alpha beta, that is equal to, these are the zeros of this polynomial. So it is equal to x square plus px plus q. Okay. On comparing these two polynomials, we will get 2 alpha plus 2 beta, that is equal to, see this one can be written as, take minus outside, so minus of minus b, minus of minus, that is plus, right? Okay. So 2 alpha plus 2 beta, that is equal to minus b. And 4 alpha beta, that is equal to q. Okay. Now, here we have what is alpha plus beta. See, this can be written as 2 into alpha plus beta is equal to minus b. Okay. And that implies substitute alpha plus beta value. That is 2 into 5 by 2 is equal to minus b. Okay. And here 4 into alpha into beta is minus 3 by 2 is equal to q. Okay. That is, here p is equal to 2 cancelled. So p is equal to minus 5 and q is equal to 2 cancelled. 2 into minus 3, that is minus 6. Okay. So p is equal to minus 5 and q is equal to minus 6. If alpha and beta are the zeros of the quadratic polynomial, p of x is equal to x square minus 4x plus 3, find the value of alpha raised to 4 beta square plus alpha square beta raised to 4. CBSE 2019 question. Okay, here it is given that alpha and beta are the zeros of the given quadratic polynomial x square minus 4x plus 3. So here, if alpha and beta are the zeros of the quadratic polynomial, then quadratic polynomial is x square minus of alpha plus beta into x plus alpha into beta. Okay, that is equal to this polynomial. Okay, x square minus 4x plus 3. Now, comparing on both sides, we get alpha plus beta is equal to 4 and alpha into beta is equal to 3. Okay. So here we need to find the value of this expression alpha raised to 4 beta square plus alpha square beta raised to 4, right? That is alpha raised to 4 beta square plus alpha square beta raised to 4. That is equal to, see here, both the terms alpha square beta square is common. So let's take it out. Alpha square beta square. Okay. See here the values of alpha plus beta and alpha into beta we have. Okay. So here we have to make the terms in alpha plus beta and alpha beta. Okay. So here we have taken alpha square beta square outside. So here remaining alpha square plus here we have taken alpha square into beta square. So here beta square. Okay. Remainder beta square. Then that is equal to here alpha beta, alpha square beta square is nothing but alpha into beta whole square. Okay, now here we can substitute directly. Alpha into beta is 3. Okay. Now how to find alpha square plus beta square? We don't have alpha square plus beta square, right? We have only alpha plus beta and alpha into beta, right? So here this can be written as, we know that alpha plus beta whole square is equal to alpha square plus beta square plus 2 alpha into beta, right? So here what is alpha square plus beta square? Alpha square plus beta square is equal to, take this one left side, so it will be alpha plus beta whole square minus 2 alpha beta. See, we can find this alpha square plus beta square substituting these values. We have alpha plus beta and alpha into beta, right? So here into, substitute this one, alpha plus beta whole square minus 2 alpha into beta. That is alpha into beta whole square is 9. Okay. 9 into here alpha plus beta whole square is alpha plus beta is 4, so its square is 16 minus 2 into 3, that is equal to 9 into 16 minus 6, that is 10, is equal to 90. So the value of alpha raised to 4 beta square plus alpha square beta raised to 4 is equal to 90. Look at this question, last year question. If alpha and beta are zeros of a quadratic polynomial, px square plus qx plus 1 form a quadratic polynomial whose zeros are 2 by alpha and 2 by beta. Okay. So first of all, what is given? Alpha and beta are the zeros of the quadratic polynomial px square plus qx plus 1. Okay. Now we know that if alpha and beta are the zeros of the quadratic polynomial, then polynomial is x square minus of alpha plus beta into x plus alpha into beta. That polynomial is equal to this one. So here before that you have to make the coefficient of x square 1. That is x square plus q by p, okay, divide throughout by p, q by p x plus 1 by p. Okay, now here we can write minus of minus q by p. Okay, now comparing both sides, here we will get alpha plus beta is equal to minus q by p and alpha into beta is equal to 1 by p. Okay, after that, see, here it is given we have to find a quadratic polynomial whose zeros are 2 by alpha and 2 by beta. Okay, that is, see, if 2 by alpha and 2 by beta are the zeros of a quadratic polynomial, then what is the polynomial? X square minus of alpha plus beta. If alpha and beta, alpha plus beta. So here 2 by alpha and 2 by beta. So 2 by alpha plus 2 by beta into x plus 2 by alpha into 2 by beta, 2 by alpha into 2 by beta, right? It is the required polynomial. Okay. Now here we have to substitute the values of alpha and beta. Okay. First of all, let's simplify this one. Here x square minus, here alpha into beta is the LCM, right? So after taking LCM we will get, see, 2 beta plus 2 alpha, right? 2 beta plus 2 alpha, so 2 is common, so 2 into alpha plus beta, denominator alpha into beta. Alpha into beta is the LCM, okay, into x plus 2 into 2, 4, 4 divided by alpha into beta. That is equal to x square minus, here what is the value of alpha plus beta? Minus q by p. Substitute it here. 2 into minus q by p divided by, what is alpha into beta? 1 by p into x plus 4 divided by alpha into beta is 1 by p. Okay, that is, it is equal to x square minus, here p cancelled, right? Denominator p and denominator of denominator, that is cancelled. So here 2 into, that is minus into minus, so plus become, okay, minus minus become plus, 2q into x plus, here 4 divided by 1 by p, that is 4p. So it is the required polynomial. Okay, x square plus 2q x plus 4p. Look at the next question, 2021 question. The zeros of the polynomial r of t is equal to minus 12t square plus k minus 3t plus 48 are additive inverse of each other, then find the value of k. Okay, so here it is given that the zeros are additive inverse of each other and given polynomial minus 12 t square. Variable is in t, okay, don't worry, in place of x they gave t, okay. So minus 12 t square plus k minus 3 t plus 48. That is r of t is equal to minus 12 t square plus k minus 3 t plus 48. Okay. Now it is given that two zeros, okay, two zeros are additive inverse of each other. That is, if a is 1 0, then minus a is another 0. That is, additive inverse of a is minus a. If minus a is 1 0, then a is another 0. Okay, that is additive inverse of minus a is a. So here let's take alpha and minus alpha are the zeros of the given polynomial. Alpha and minus alpha. Okay, let alpha and minus alpha be the zeros of this polynomial, that is minus 12 t square plus k minus 3 t plus 48. Now here let's make the coefficient of t square 1. Okay, for that we have to divide throughout by minus 12. Okay, so it is equal to t square divide throughout by minus 12, okay, plus k minus 3 by minus 12 t plus 48 divided by minus 12. Okay, that is equal to t square minus of k minus 3 by 12 t. Here 48 by minus 12 is nothing but minus 4. Right? Okay. And we know that if alpha and beta are the zeros of the polynomial, then polynomial will be x square minus alpha plus beta x plus alpha into beta. Here x square, alpha and minus alpha are the zeros. So here let's take the variable t itself. Okay, so t square minus of alpha plus beta. Here alpha plus minus alpha t plus alpha into minus alpha into minus alpha. Okay, that is equal to t square. Here alpha plus minus alpha is nothing but 0 t minus alpha square. Okay, and we know that alpha and minus alpha are the zeros of this polynomial, and alpha and minus alpha are the zeros of this polynomial. So this polynomial is equal to this one. Okay, so it is equal to t square minus k minus 3 divided by 12 t minus 4. Now comparing on both sides, here we will get, see what is coefficient of t here? 0. Coefficient of t, k minus 3 by 12. So k minus 3 divided by 12 is equal to 0. That implies k is equal to, take this 12 here, so k is equal to 3. Okay, take this 12 here, it will become 0. So k minus 3 is equal to 0, k is equal to 3. Here alpha square, that is minus alpha square. Okay, minus alpha square. What is the constant term in left side? Minus alpha square. In right side, minus 4. Minus alpha square is equal to minus 4. Here we don't need to find the value of alpha. Here we are asked to find only the value of k. Okay, so it's enough. See, if you are asked to find the value of alpha, you just, that is, compare constant terms. Here alpha square, minus alpha square is equal to minus 4. That is, alpha square is equal to 4. That implies alpha is equal to, alpha square is equal to 4. Alpha is equal to plus or minus 2. Plus 2, minus 2. These are the zeros. Okay, so here we need to find the value of k, right? So k is equal to, value of k is